Good day, everyone. We are the researchers from Camarines Polytechnic Colleges that conducted the thesis entitled Automated Temperature and Humidity Control for Hydroponic Garden using Physiological. Hydroponics is a modern method of farming that uses water mixed with a complete nutrient solution needed by a particular plant and put in a protected structures like rain and shade tents or a greenhouse. To combat high temperatures and high humidity in warm areas such as Philippines, most hydroponics growers in lowland areas use digital misting systems to lower the temperature and different kinds of fans to ventilate the area and lower the humidity. Some opt to manually spray water on the lettuce to retain the moisture and cool down the area since it's budget-friendly. However, it's not that effective and efficient, as most farmers only depend on what they feel about the temperature and humidity. Using a control system with Physiologic, the ideal temperature 18 to 34 degrees Celsius and humidity 50 to 70% can be maintained. Hence, this study focused on developing an automated temperature and humidity control system using Physiologic algorithm. Specifically, this study aimed at designing a Physiologic controller and integrating the firmware into the system. Furthermore, test and evaluate the developed control system with Physiologic in terms of maintaining the ideal temperature and humidity for optimal growth of lettuce, which is 18 to 34 degrees Celsius and 50 to 70% relative humidity, and the effectiveness of Physiologic control system in preventing the occurrence of physiological disorders in lettuce such as prematurely bolting, tip burns, and wilting. This study will be beneficial to the growers that located in tropical areas to combat heat in their hydroponic setup and be knowledgeable about the proper misting to avoid the occurrence of physiological effects in the plants. Future researchers. This study would be useful for the future researchers and use the various processes and techniques used in this study. In the field of computing, the community of developers and technology enthusiasts who are developing a device will be beneficial and can apply the results of this study to develop modern agricultural system. Agriculture technology. This study could serve as the ever-changing innovation to farming practices in modern agricultural system. The Physiologic controller that could set the ideal temperature and humidity will help the agriculture technology sector increase the efficiency in production when it comes to farming. Here are the materials or components used in making the prototype of the control system. ESP32. The microcontroller is the brain of the entire system where it is used to control the electronic relay, read the sensor data, and send the data to display to LCD and read the button state. DHT22 sensor. The sensor is for reading the current temperature and humidity of the greenhouse where the Physiologic gets its input. LCD. The LCD displays all the necessary information of the sensor, pump status, the Wi-Fi connection, and the logging status. I2C module. I2C module is added to decrease the complexity of connecting the LCD to the microcontroller, where it can be interfaced with only 4 connections including the power. Push button or tactile switch. The 2 buttons in the system are used for cycling the display from the sensor values, Wi-Fi, logging status, and turning the backlight on and off. Resistor. The resistors are used as pull-down resistors to avoid floating values on the button pins. 2-channel relay. The electronic relay is for turning on and off the pump and fan to control the greenhouse humidity and temperature. The design of Physiologic controller was done with the use of MATLAB Physiologic toolbox. It has resulted in easy simulation of inputs, rules, and outputs to the controller, providing unexpected outputs during the integration. The integration of the controller to the system turned out quick and easy due to available Physiologic library for Arduino, which can also be used on the ESP32, programming it with the Arduino framework. Also, the system integration resulted with a few notable issues like non-feeding on the sensor and the certain GPIO pin on the microcontroller becoming faulty when the microcontroller is not on monitor mode. However, since the integration of the system was done through the use of prototyping breadboard, all the encountered issue during the integration was easily resolved due to flexibility of the prototype. The control system with Physiologic was able to execute the task or action needed based on the Physi rules, and was able to maintain the ideal temperature set in this study. However, it took a long time to reach the ideal temperature, mainly when the control system was not triggered to switch on the horizontal airflow fan. The fan helps circulate the air and the cooling down of the environment inside was shortened. For temperature control, it is much better to use the pump with a horizontal airflow fan for air movement based on the gathered results, as it helps in quick cooling of the area. Therefore, the researchers concluded that the control system with physiologic would maintain the temperature but not the relative humidity of the garden and was very effective in avoiding the occurrence of physiological disorders such as wilting, tip burns, and early bolting.